Hello everyone, you're welcome to this session of the class, which is a GitHub for Bioinformatics. And in this session, I will be taking us through uh, the basics, the fundamental basics of GitHub, and what are the benefits for being a bioinformatician. But first, let us know what GitHub is. A lot of us just heard of the name GitHub. GitHub, it's like the a kind of trendy name that goes around, especially by informatician or data analysts or coders or programmers and the likes, or software engineering. But GitHub is basically a web-based platform that provides a range of services for software development, collaboration, and version control. And the tool it's used in doing this, performing this function, is called the GIT. So GIT is a distributed version control system. So all these are terminologies that are known among the engineers, software engineers, and programmers. So what this basically does is that what it does is that it tracks changes in any set of computer files, usually among programmers and coders. So it's just a collaborative tool, an open source resource, whereby people can work from different parts of the world on a particular set of projects. Now, there is a term that is also called a version control. So it's a class of system responsible for managing changes to computer programs. So now, another terminology that I try to break down is that distributed version control is a form of version control in which the complete code base, including its full history, is mirrored on every developer's computer. So that means we have an original and then we have a photocopy of that program across different computer systems. So GitHub enhances collaboration. It makes your work accessible to a lot of other people, and you can easily develop your code by collaborating with other people. So how does that concern us as bioinformaticians? We all know by definition, bioinformatics needs software. It needs code, especially when you are dealing with a large data set. So that is where GitHub comes to assist. So it enables us to reproduce the data that a particular scientist have worked on. So with GitHub, you can easily see their data and then collaborate with them on that. So you can see the source code that they use in coming up or developing a software that performs bioinformatics work. And there are different collaborative software. The most popular one is just the GitHub. They also have the Bitbucket, GitLab, SourceForge, and the likes. So the most popular one is GitHub, and it has been since been acquired by Microsoft, I think in 2016. So it is essential for collaborative work. So one of the main advantages of using the GitHub is that it is popular, it is web-based, it is free, and it offers you integrated environment for hosting a source code, documentation, and anything relating to your projects. So it also, of course, it also offers paid plans for private repositories for individuals and businesses. Now, I need to point out the fact that as you move along in your bioinformatics journey, uh, you get to a certain stage, there is a certain level in which you would need data analytics skills, and it is very, very important. Apart from that, you also need to know about all these cloud databases. So one of the most popular cloud database that is common among bioinformaticians is the Amazon Web Services. Now, I also have to put than an introduction, in the sense that a very serious bioinformatics lab would always have their own private server. They would always have their own private server. In their private server, that is where they can store their data, and anywhere they are in the world, they can easily pull their data from that web server. So not all servers are on the cloud. Now, what cloud services does is that you don't need to have a physical server set up in your location. So you just buy a space, and then you have your web server hosted by either Microsoft through Azure, or through Amazon Web Services through Amazon. There is a third player in the cloud computing service. I've forgotten. We have Microsoft Azure, Amazon with AWS. We also have, I think, Facebook also has a web services. So these are by the way. So every serious bioinformatics lab would have a server. Now, and what this server does is that it makes collaboration between researchers easy in that particular laboratory. So in GitHub, it's a private repository, but sometimes you will need to buy a space for repository for individuals, so that you can collaborate for research and educational use. Now, there's a journal that has they published the 10 rules on using GitHub, for especially for bioinformatician, and I've tried to break it down here. So the first rule is that the first benefit, so to say, is that you can use GitHub to track your project. So that's one of the benefits. So you can see, as you're working, every other person will see your work. They will see your code. If you make a mistake, they will note it down. There is also different tools that are being used for that kind of collaborative work, not just GitHub, especially when it comes to writing. We also have there is this writing service. Although I don't use it, I don't use the writing service. Just like we have a Mendeley for referencing. We also have LaTeX. Yes, LaTeX, that's the name. It is spelled LATEX, but it is called LaTeX. So LaTeX also performs this function of tracking your work. If you invite people to that particular project, they will see every change, the dates in which the changes were made, so it will be noted down and everything of such. So that's one of the functionalities of GitHub. So GitHub is also beneficial for single users, for teams and organizations. It depends on how you want to use it. So it is used for developing and collaborating on new features, and this is through the branching and forking method. So in the time fork, FORK, so you can have access to a particular project that's been done in a repository by someone else, and then you will create a copy of such content in your own repository, and then you can apply, seek permission to work on that, to fork that work, so that you can use it for your own work. So you can easily experiment without affecting the original project, and forms the basis of social coding. So it's very important. It's very forking is used, and also the branching tool. Now we also have the naming branches and commits, and tag semantic versions. So all these are also to give us the processes in which a particular code that is being used is being updated every now and then. So by this method, you can note the bugs in the code, the date, and what the major update that has been done, and it is used to document the versions of a particular app, particular code, or particular system, or particular software. So it is done here. There are lots of collaborative work, even strangers, that they will just use your code, and they will see that, oh, let me repurpose this code for something else, and then from that you will see an advancement in that. So need I point out that GitHub was also developed based on the Linux environment. So this is an advancement that we get to as we grow along the line in our bioinformatics journey. Linux is important to that. So we also have the integration in GitHub. So GitHub can do some tasks for you. So it does tasks for you, but not like the normal software that we know of. So we also have what we call automation in GitHub. So in GitHub you can do more you can automate your work. We also use GitHub to openly and collaboratively discuss and address and close issues. So of course it's a collaborative tool. Likewise, you can make your code easily citable. Of course, sometimes you might have seen a work that they use GitHub repository. So maybe you've come across that. They will give you the link to the GitHub repository whereby you can see all the files, all the codes they used for their work. You can promote and discuss your projects, and also of course you can use GitHub to be social. So sometimes you don't give your LinkedIn address, just give us your GitHub address if you are serious about a particular work. Maybe you call yourself a bioinformatician and you say you have been working on R, on Python and the likes. So people that wants to hire you, they will want to see an evidence that you are versatile in that field. So it is used as a social currency. Now we'll move to try and open GitHub in interface. Just type github.com and then you come to this particular web interface. So I think I have an account, but I'm not sure, so we'll open an account together by signing up. So time depends in that username, and from there use. So now one of the so when you go through it, these are repository accounts. So you can see a picture. It's like a social media account. So you can follow her from this from our account here. It gives a very short address about who she is. Halima Chisom Atoda, Chisom Gold. You can follow, but I can't follow because I do not have an account. Yes, so it tells me to sign in. I haven't registered my account yet, so I can't follow. Now the LinkedIn account, the Twitter account, the more followers and the more following, and then from here you can see the repository. Okay, let's start from the overview. So we have the overview about who she is. So an introduction. Hi, I'm Alimat. You can do that. You can introduce yourself here, and then popular repositories in which she has worked on or she has used in our experience so far on GitHub. Now when you click on repository, you can see all the repositories that she has worked with. Now from here, we talked about forked earlier on. So she forked this spoon knife project from this project AutoCAD. So you can see the same thing for use star key, develop blah 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 blah. You can see data analysis forked. So you can also do your own starting from the beginning. This is another forked file. As you can see, it goes on and on depending on what or how versatile you are with your work. So that is one of the joys, that's one of the beauties of collaborating. Now you have the projects that she has worked on. there aren't any projects on, and there aren't any projects yet. The packages that probably she has used, and she has uploaded, so, and the likes, so the number of stars are here. However, as important as the GitHub is in the terms of being important, not everyone would have a GitHub account. I personally, I don't use GitHub because most of my work I don't necessarily need to code or do any coding before my work is done. But that doesn't mean that you cannot have an account in GitHub. So I do have an account before, but I don't use it. So it doesn't necessarily mean that if you are not on GitHub, you are not a you are not a researcher. So, but it is good to have one because that's what it's like a social capital. Like now, if I want to prove my expertise as a bioinformatician, I'd rather show you my publication rather than sending you my GitHub account. So still okay, message comes, let about you coming up. So you can just come to home here, GitHub home, and explore. So okay, we come back to initial stage here. Now email to continue. So continue. You have to choose one, 7, 2, so probably an email has been sent. Let's see. So I still expect the email to come, but nothing yet. But once you verify, you'll be your account or account. So basically, it's a collaborative tool. It's open source. You can search. You can jump on any code if you have the experience and the expertise to do that, and you can. Okay, let us open one of the repositories that we have here. So you can click on any and see how it looks like. So let's click on one, just one, genomic alignment, and then yeah, this is what it looks like when you come in. So, but as someone who has no background in coding or programming, I would this will just be a fool's errand if you are just bothering yourself or getting worked up about goes on here, because you won't understand what uh, what it's what it is. So as you can see, we've opened this. So these are just codes that are used to carry out a particular work. So, and this is for R code and the like. So you don't need to get yourself worked up if you do not know how to use uh, GitHub, but one step at a time. So you can search for, so let us search for something. Let us search for metagenomics and see what comes out of metagenomics. So yeah, you can see a lot of repositories, languages, advances and the likes on metagenomics. So as you can see, interactive analysis of metagenomics data pipeline, read coverage calculator, classifier, complete pipeline, workshop materials for shortcut metagenomics. Yeah, so this is another usefulness of GitHub. So it's not just about the code. You can upload materials that are being written by maybe using R. There is another way you can write your like paper on R. So these are codes relating to metagenomics. So you can open each and every one of the files. You can, as you can see here, you can see the date, the last update that was done on the work. So you can start, you can just check it out. You can copy it for your own. You can fork, you can branch as you see fit. But for someone just starting out, don't complicate matters for yourself. So there's a reason we didn't include it as part of our curriculum to be treated in this class. So this is just to give us a broad overview of what it is. As you can see, you can navigate the items here, the solutions, the pricing. Is it for teams, for education, for startups and the likes? So you can search and explore as you wish. So that is a short brief introduction into what GitHub is. So let me know if you've tried, if you're able to open finally GitHub account. So see you